Hello, everyone. This is modeling errors in Now CLI. Thank you for the sponsors. And yes, hi. I wanted to ask you, how many of you are familiar with this here? Undefined is not a function. Sounds familiar, kind of, right? A little bit, yeah. And what about this type error, whatever variable function is not a function? Pretty much, right? And what about this? And this? And this? No, this is not a 500 anymore, right? But do you know what do they have in common? Not this one, but the rest of the slides. They are all errors, right? And we always tend to oversee those errors. It is very easy to see a service, an action service, complicated service with like, let's say 5, 6 actions with a wait calls and no try catch at all. So when that fails, you are like, you are not doing anything, right? So you are like, well, yeah, but I don't really expect to have any errors there, right? But you know what? I have bad news. Shit happens. Things tend to break all the time. And it's not always our fault. Maybe there are some external agents that can make our program fail. But we have to be aware of the problem all the time. But let me ask you something. What is the reason why we don't control errors? I think that maybe one of those reasons is the lack of context. Let me get this straight. So you have a function, you call that function, and maybe it throws an error. And then when you're catching that error, you say, okay, I have to tell the user whatever. But, oh, you missed a variable there. Maybe you don't know what is the domain. Maybe you're losing information that you want to show to the user. And it's way too hard to get that information back, so you say, let's leave this shitty message. It's fine, actually, right? Or maybe it's because you have an unknown error space, because you're consuming an external API or an external library or something, and you don't even know what are the errors that that function can throw. So you are just not familiar with the error space. But in general, I'd say that we are always overseeing errors because we are super lazy. It takes a ton like pattern match 10 different errors to show a proper error message, to tell the user what to do. But yeah, the real thing is that we don't give a fuck about the errors, honestly. I do, in general, not always. But also, we don't seem to understand how important it is to handle errors properties. Let me give you an example. Anyone's familiar with this component catch? Sounds familiar? Let me ask you now, how many of you use regularly component catch? Okay, liars. Nobody uses that component catch. So yeah, errors are important. We are going to speak the next 10 minutes or so about errors. My name is JAVI Velasco. I work for this company site. Many of you, if you're familiar with JavaScript and the JavaScript ecosystem, probably already heard about it. That is my Twitter handle, catch it now, because it's the only slide with the handle, actually. That's me and my beautiful dog. So yeah, I work for this company site. If you are familiar with it, you might wonder that we have over 100 microservices. And that is actually, when you have so many microservices that are collaborating with each other, that aggregates a lot of complexity. And REST APIs are exposed in many of those microservices, which means that there is a final consumer, which is you as a developer, so we have to provide you with meaningful errors, so you know what's going on there when you do something wrong, or maybe there is some state that is wrong in the backend. There's too many shit that can go wrong in this, especially with these APIs that we have to expose. So in case, when it comes to error handling, I think that one question that you have to ask yourself is, what is the entry of your program? Because what you have to think, what the consumer is actually seeing. In the case of an API, it's pretty simple. It's just the API response. So let's focus for now in that specific case. In our case, we came up with a super tiny solution. It's very simple. We just have like a higher order function that you can use to wrap the endpoint. We get into we define like a simple contract that defines what is a known error and an unknown error. So in our case, a known error consists of an error prototype, an instance of an error, with a proper payload and a specific set of fields. One of those is the response code. So when an error gets to that point with that response code, we are going to send a proper response code, and we are going to read the payload to show a proper error, and otherwise it would be a 500 and uncontrolled error. The problem is that one might be tempted to do something like this, which is just creating a new errors instance and then assign those fields there. Like, for example, that would be an error for an invalid domain, a validation error. And yeah, the problem with this is that the good thing about this is that later we can just inspect those fields to get to know what is the error. But the problem is that we are not really reusing this error. If I have another point in my code where the same error is happening, there is no way of reusing this. So you have to come up with a structure to represent an error properly with all of this context. And the best idea we came so far is having a class, something like this that extends from error. So we can use all of these properties that the error prototype already has and also add some new fields that are meaningful for the purpose of the error. So in the API, or APS in general, it's very common to find an error.js file that has like a huge list with all the domain errors that can happen. And the way to use it is actually even simpler, because you just need to require or import that constructor, and then you just throw new whatever is the error with the appropriate payload. Yeah, so this is a way to control errors in our APIs. But actually, if you consider that all those microservices are working together, we also have a product, which is the core product of the company, which is called Now. Probably many of you are familiar with it, but there are some commands in Now that can generate error that might come from tons of different APIs, depending on how the process is going. And for those that don't know about Now CLI, basically it allows you to take your JavaScript or Docker-powered website and put it in the cloud with easy speed and reliability. Basically, any directory that contains a package.json or a Docker file can be super easily transported to the cloud in just one command. And one of the features in Now is to create aliases. So imagine that you have a deployment with that URL. Then you can say, I want this address, this another.javi.sh to point to that deployment. In this case, and specifically, we are communicating many APIs. We are communicating the domains API to verify that you own that domain. And maybe if you don't, we have to go to the domains availability API to check if that domain is available in order to show you to you so you can buy it. Then we have to check another API to check the actual price. Or maybe if that doesn't happen, it turns out that you don't have a certificate for the domain. So we have to call these APIs, certificate API, to generate a certificate. So each of these APIs can fail for many different reasons. But in the CLI implementation, what you have in the end is a function, create alias, that receives a very close set of parameters. In this case, the alias name, deployment URL, the user ID, and the team ID. So yeah, we just have this function that takes this small amount of parameters and many things that go wrong. So how can you control that? How can you prevent that from breaking? It's very easy. You just put a try catch in there. I'm sorry, for some reason your error didn't work. I'm sorry. What to do with this, right? But now seriously, just imagine that there is an error where the user needs to take action. Like, for example, imagine that you have to generate the certificate yourself, so you have to run a different command. I have to give you enough context so you know how to fix the error and then come back and run the command again. So in this specific case, error handling is crucial. It's super, super important. So let's see how can we solve this in Now CLI. First of all, something that we can do following a similar approach is, since we know that all of our APIs are returning known errors in a similar format, what we can do is to wrap our fetch function so we can inspect the status in the response, and then in case that the response is including an error, we can create a well-known error called API error, whose payload is just the error, and we can throw that one. So afterwards, when you have going back to this create alias function, you can see that we can just try, catch the error, and then we check if it's the instance of an API error. And in that case, we already know something. There was an error, and it came from the API. So maybe we can just show the message, and it's not going to provide enough context, but it's better than nothing, right? So what happens here, and the problem why you can't really do this all the time, is that we want to provide meaningful messages to the user. And the context of Now CLI is completely different from the API context. For example, we have a concept in Now CLI, which is the context itself, that tells if you are in a team right now, or if you are your user alone, or who's operating with that command. And in that case, the information is important, because if you are missing the domain, maybe I have to tell you, I couldn't find the domain in the context that you are right now. Right? Because maybe you are not aware of the context in that particular moment. So you have to provide more context in the front end than the context that you have in the API. A way to fix this is to model errors in the CLI as well. So for example, let's say that you identify the single piece that can fail, which is the actual function that performs the API call. If you go now to this hypothetical list of errors that you have in the backend, you can just get all of those error codes and then pattern match to create more meaningful errors. In this case, for example, we are checking the error code, and in case the error is cert missing, we are going to create this new cert missing for alias record, whatever, that is loaded with more information, the context, the domain, deployment URL, and alias and everything. And then we go and throw that error instead of the original one. That means that in the upper function, in the entry point, create alias, you can again catch the error, but then instead of comparing with the API error, you can compare directly with the constructor of that particular error. And in case the pattern, the matching is positive, you can provide a really meaningful response. Like for example, here you can say there is no search for the domain, and then you inspect the payload to know what is the domain. So we can alias whatever the alias. And then you can even check additional information that is coming from the backend to decide whether you have to run one command or another to fix the problem. And in case it doesn't match, you can still check with an API error because you know that there must be most stuff that can go wrong. So, and in any other case, I'm sorry, I don't know what happened, right? So let me ask you, what are the errors that a function can throw? And the response is, I don't know. What can that function throw? Because imagine that you have this small function, and then you reuse that function somewhere else. And that function can throw something new, but you never get to notice in the consumers. It just fails one day, and you say, well, what is this error doing here? And then you check, and you see that there was this function buried somewhere that was throwing and popping up the error to the top of the call stack. So you can't really be sure. So you might say, okay, instead of throwing, we can go and return the errors. Because I think that the error itself can be considered a result of the function. Like in this case, we are always calling a function and we expect to receive a proper response. But the error is also a response. And instead of getting the response, what we are going to do is just to throw. So there is no difference between known and unknown errors in terms of how the function is behaving. So what happens if we decide to return the error? Well, what's happening is something like that. If you identify the error, then you are going to treat it properly and return it. And otherwise, you are going to throw the error. So what's going on there? Now, what are the errors that the function can throw? Only unexpected. But let me ask you, what are the errors that the function, excuse me? There you go. What are the errors that the function can return? You don't know either. You don't know what are the errors the function can return still, because JavaScript, right? It's just JavaScript. So we don't really know. Maybe, apparently there is some shitty layer that you can put on top of your project, so Babel doesn't work anymore. It's something like typings or something like that. Like Flow, for example. You can use Flow. Your project is not going to work anymore, probably. But then you get it right at some point. And you can type your function. And when you start typing your function, you can say specifically what is the behavior of that function. And when you run this API call, you can say this is going to return a promise that returns either on this error, this error, this error, or the success. And the good thing about that is that you can have a signature on top of your code that is going to be something like that. So you are going to see explicitly that this function can return all of those errors that can be inferred by Flow directly. And if you go inside of this whole flow and add a new function that returns a new type of error, Flow is going to complain if you don't handle that error, because you are assuming that the return value is something that is wrong. So basically, it should be something like this. You can call this function create alias, and imagine that you treat this error set missing for alias. But then you don't treat anything else. So you are going to output log result.alias. Well, if the function is returning more errors, not only that error, Flow is going to complain, and it's going to tell you, hey, alias maybe doesn't exist in this particular result. But of course, there are caveats to this, and this is just an attempt to solve this problem. But let me show. Well, that was supposed to be an actual slide, but shit happens, you know? Well, thank you very much. That's it. Questions? Any questions? No? 1, 2, 3, 4, no? Yeah, question. We have a question there.
Hey, thank you for a nice speech. And have you made any researches to solve your problem via aspect-oriented programming?
Again, sorry?
Do you know about aspect-oriented programming paradigm?
Sounds familiar, but I am not really familiar with it.
You could provide the default implementation when you, for example, have methods that throws an exception, and provide the same behavior in every place of code you could provide it.
Cool. I'm not aware of that, actually. Yeah.
So,
but wait, we can speak about that later.
Oh, okay.
Yeah. Sure. Yeah. Okay, that's it.
Hi. Just for recap, you can.
Sorry. Yeah.
Yeah. No, for example, you can. I guess the other guy was.
These guys, I can hear anything.
I guess the other guy was referring to apply like default behaviors and to have the proper way to know at the signature of the method what is going to throw. I mean, instead of
instead of implementing instead of doing that, you do that in the try catch. I got it.
On catching the error on the body of the method, doing, for example, using a decorator as a Spring with Java framework Spring class.
Yeah. Got it. Yeah, I'm gonna check for that. Sounds good.
You never use it, or?
No.
Okay.
No,
just later I will show you some example.
Hey.
Thank you, Javi.
Yeah, thank you.